Good morning to everyone. My name is Xuan and battery number 263570. Today I'm going to present about my industrial statistic project 2, which the title is Forecasting on Crude Palm Oil Production in Malaysia. My supervisor is Prof. Maya Dr. Noor Aisha binti Ahad. Next, I'm going to present about the introduction. The introduction in this study has covered several parts. Firstly, background of study. Palm oil fruit were known as fresh fruit bunches since it grows in dense bunches. Fresh fruit bunches and natural rubber was known as the major commodity crops used in Malaysia. Indonesia and Malaysia are the top two oil palm fruit producers across the world. Oil palm fruits will be processed into crude palm oil, while the nuts and kernels will be processed into palm kernel oil. The crude palm oil is then processed at a palm oil mill into edible oils, oleochemicals, biodiesels, and lauric acids. These two figures shows the production of major crops in Malaysia in 2018 and 2019, and also the production of fresh fruit bunch by country in 2018. A forecast is the prediction of some future events. The purpose is to provide managers with information that will facilitate decision making. Forecasting horizon can be divided into three types, which include short-term forecasting, medium-term forecasting, and long-term forecasting. Forecasting can be categorized into two methods, which are qualitative forecasting and quantitative forecasting. Thus, long-term forecasting and quantitative forecasting will be focused in this study. In this study, the forecasting method will be used to predict the crude palm oil production in Malaysia. Analyzing and predicting agricultural data assists in understanding and forecasting the production of crop growth, allowing planners and policymakers in government and corporations to make relevant judgments about import-export policies, crop production monitoring, procurement issues, and proposals for improved crop methods for high productivity. Next problem statement. Malaysia, as the world's second largest producer of palm oil, requires a huge amount of the production of fresh fruit bunch to make crude palm oil and palm kernel oil for export to other countries. To achieve the demand for crude palm oil for export, forecast the production of crude palm oil is needed. We are going to identify the trend of crude palm oil production in Malaysia and also the best forecasting model among the chosen forecasting model. We also forecast the production of crude palm oil in Malaysia from September 2021 to December 2026. The objective in this study is to identify the trend of crude palm oil production in Malaysia from January 2010 to August 2021, determine the best forecasting model, and forecast the production of crude palm oil in Malaysia from September 2021 to December 2026. The significance of this study is to benefit Malaysia government and non-government organizations to plan policy and crude palm oil management in the future. This study also assists agriculturalist management in reducing overspending, scheduling productivity and labor, and also avoiding missing potential opportunities. The literature review in this study has covered several parts. Firstly, crude palm oil production. According to Ramli Abdullah, the author has conducted a study and analyzed crude palm oil production in Malaysia. In this study, the author has discussed the characteristics of crude palm oil production in Malaysia and also the factors affecting crude palm oil production. Crude palm oil production in Malaysia can be classified into four components such as trend, seasonal, cyclical, and irregular components according to a previous study. Moreover, the production of crude palm oil in Malaysia can be affected by four main factors, which included natured areas, rainfall, fertilizer application, and lastly, replanting programs. Next, the literature review on forecasting method. A previous study by Oster-Tagova et al. They discussed that simple exponential smoothing is the most often used forecasting method for predicting the next period of a time series with no discernible trend or seasonality. It also only useful for non-seasonal patterns with approximately zero trends and short-term forecasting. According to Kaleka, the seasonal time series modeling by hot winters exponential smoothing approach is applied since there is both trend and seasonality in the dataset. It can be classified into two types, which is additive and multiplicative model. The error measure applied to identify the best parameter is the mean absolute percentage error. Next, the literature review on forecasting on crude palm oil production. According to Tayyip et al., they forecast the crude palm oil production in Malaysia by applying Sarima model. They collected the data of production of crude palm oil in Malaysia from January 2014 to September 2019 from the website of the Malaysia Palm Oil Board. The best forecasting model is Sarima 1000011 model. A previous study by Nozada et al. They forecast the total planted area and yield of oil palm in Malaysia by applying linear trend model, double exponential smoothing, and autoregressive integrated moving average model. They collected the yearly data of yield per hectare of fresh fruit bunches yield 15 1974 to 2016. In conclusion, the best model in predicting the total area of oil palm planted is ARIMA 223, while ARIMA 011 is the best forecasting model in forecasting the yield of oil palm since it produces the smallest values of MAPE and MAT. Next, methodology. This research is exploratory research. The type of data is secondary data. The data is collected from Department of Statistics Malaysia, which consists of monthly data of crude palm oil production in Malaysia from January 2010 to August 2021. Next, partitioning data. According to Atika and Pragna, the suggestion of ratio of partitioning the data are 80 to 20 and 90 to 10. However, Philip mentioned that the outcome which follows 90 to 10 is more accurate. Thus, in this study, the data is partitioned by 90 to 10 ratio rule. Next, method of data analysis. The first step is to identify the time series data patterns such as trend and seasonal. The time series data pattern is identified by plotting time series graph, analyzing autocorrelation and Kruskal-Wallis stats. The second step is formulation of forecasting models such as NIF trend and seasonality model, decomposition additive and multiplicative model, hot winters trend and seasonality exponential smoothing additive and multiplicative model, autoregressive integrated moving average model, and seasonal autoregressive integrated moving average model. Next step is forecast error. The forecast error that applied in this study is mean absolute deviation, mean square error, root mean square error, mean absolute percentage error, and mean percentage error. The production of crude palm oil from September 2021 to December 2026 is forecasted in this study. The statistical tool used in this study is Microsoft Excel, SPSS, and R programming. Data analysis and result. The data in this study is split into two parts, which 90% for modeling, which the data is from January 2010 to June 2020, and the remaining 10% is for evaluation, which the data is from July 2020 to August 2021. This three figure shows the result of time series plot, autocorrelation plot, and Kruskal-Wallis stat. From this three figure, we found that the data pattern of crude palm oil production is trend and seasonality. Next, evaluation of forecast error. This table shows the forecast error for modeling part. From this table, the SARIMA 100010 has the smallest value of MAT, MSE, RMSE, MAPE, and MPE. This table shows the forecast error for evaluation part. From this table, the model that has the smallest value of MAT, MSE, RMSE, MAPE, and MPE is SARIMA 100010 model. From these two tables, we can find that the best forecasting model is SARIMA 100010. Forecast of crude palm oil production. This figure shows the forecast production of crude palm oil in Malaysia. From these figures, we can conclude that the forecast production of crude palm oil in Malaysia remains unchanged from September 2021 until December 2026. Next, conclusion. In conclusion, the data of production of crude palm oil in Malaysia consists of trend and seasonal components. The best forecasting model is SARIMA 100010 model. The forecasted production of crude palm oil in Malaysia is concluded to remain unchanged from September 2021 to December 2026. There are several limitations in this study. Firstly, limited previous studies regarding this topic. Hence, we also include the previous study of forecasting on crude palm oil prices in this study. Second, limited access to data. The website of Department of Statistics Malaysia only provided the crude palm oil production start from 2010. The contribution of the study is to benefit Malaysia government and organization to plan policy and crude palm oil management in the future and assist agriculturist management in reducing overspending, scheduling productivity and labor, and avoiding missing potential opportunities. The recommendation in this study is to search the previous study that regarding to this topic from other countries, and we can also apply forecasting method on other topics regarding to oil palm such as price, planted area, and so on. These are my reference in this study. That's all from me. Thank you.